Welcome to The Explainer. Today, we're going to pull back the curtain on a process that affects every single one of us every day, but that most of us, well, we never even see it. We're talking about software testing. Let's get into it. You ever stop and think about how the countless apps on your phone, from your banking app to your favorite game, somehow manage to work without constantly crashing? I mean, how do they handle millions of users all at once? It really does feel like magic, but I promise you, it's anything but. And here's the part that might just surprise you. The whole process of making sure an app works perfectly, it doesn't start when the software is finished. No, it starts right at the very beginning, by looking at the project's documents and designs way before anyone writes a single line of code.
So before we dive into the nuts and bolts of how testing is done, we really need to get our heads around the mindset behind it all. It's really a philosophy of quality.
You've probably heard these terms thrown around: quality assurance, quality control, maybe even used like they're the same thing. But in the software world, they mean very, very different things. Let's break that down. Okay, think of it this way. Quality assurance, or QA, is all about prevention. It's proactive. It's about looking at the entire process to stop bugs from ever happening in the first place. On the other hand, you have quality control, or QC, which is all about detection. It's reactive. It focuses on the finished product to find any bugs that manage to slip through. It's like one builds a fence at the top of the cliff, while the other parks an ambulance at the bottom.
So, if quality starts before the code is even run, what does that actually look like? Well, this brings us to our first major category of testing. A good analogy is like an architect checking the blueprint for a skyscraper. You want to find any mistakes right there on paper, long before you start pouring any concrete.
And that's exactly what static testing is. It's this methodical review of all the project documents, the requirements, the design plans, even the code itself, all without ever hitting run. And the reason is simple. A mistake found in a document is exponentially cheaper and easier to fix than a bug that's found in a live app already in the hands of millions of users. Now, static testing isn't just one single activity. It's really a whole spectrum of techniques, each one with a different level of formality, designed for different kinds of situations. It can be anything from a quick solo chat to a super structured team meeting.
At the most informal end of that spectrum, you've got the review. This is basically just someone on the team reading a document on their own, checking to see if it makes sense and if it's complete. It's that fundamental first pass. A step up from that is the walkthrough. This is a bit more collaborative. The author gets a few of their peers together for a casual meeting to literally walk them through the document and get some immediate feedback.
And finally, at the most formal end, you have the inspection. This is the big one. It's a highly structured, pre-planned meeting with one single goal: to systematically hunt for defects. It's a formal process where everyone has a defined role. In a formal inspection, every role is crystal clear. The moderator is in charge, leading the meeting. The reader, who's usually the author, presents the document. And then you have the writer, whose only job is to capture every single issue that's raised. This tight structure makes sure absolutely nothing gets missed. All right, so we've checked the blueprints. They're solid. Now it's time to test the building itself. This is where we shift gears from the theoretical to the practical, and we enter the world of dynamic testing. So unlike static testing, dynamic testing is all about executing the code. We're actually running the software. The core idea is pretty simple. You give the program an input, and you check if the output it gives you back is what you expected, right? Does the login button actually log you in? Does the add to cart button actually, add the item to your cart? But dynamic testing isn't just a free-for-all. It happens in 4 distinct escalating levels. First, you have unit testing, where developers check the tiniest individual piece of code, like a single button. Next up is integration testing, which is where we see if all those little pieces work together. Then comes system testing, where the entire fully built application is tested from start to finish. And finally, the most critical step, user acceptance testing, or UAT, where actual users get their hands on it to see if it really meets their needs. So let's zoom in on that second step, because making sure all the pieces fit together is absolutely crucial. Okay, so we're going to zoom in on integration testing. Why this one? Well, because a software app isn't one giant piece of code. It's made up of dozens, sometimes hundreds of smaller bits called modules that all need to talk to each other perfectly. This is where we make sure they do. So, in short, integration testing is all about checking the handshakes between different parts of the software. When you log in, does your user profile information actually make it to the main screen? When you delete an email, does it correctly move from the inbox part to the trash part? That's what we're testing here.
Now, there are 2 main ways to do this. First is the top-down approach. You start with a big, high-level parent module, like the main screen of an app, and then you add and test the smaller child modules one by one, like the buttons on that screen. Or you can do the bottom-up approach, which is the exact opposite. You start by testing the smallest child modules first, and then you gradually add the parent modules on top, building the system up from its foundation.
But look, whether you start from the top or build from the bottom, the ultimate goal is always the same. It's all about making sure that when you connect all these different pieces of the puzzle, they form a perfect picture and can talk to each other without any issues at all.
So when you think about it, we've gone from the high-level philosophy of preventing versus detecting flaws to checking the blueprints with static testing, all the way through these multiple levels of live dynamic testing. It's an incredibly thorough process. Which really leads to one final important question. With all these layers of protection, why do bugs still make it out to us, the users?